strong in the sheltered area, while in the more exposed area there is lots of wave action. Then we have two horizontal lines representing the tidal action. What is beneath the first or the lowest horizontal line is the subtidal area. So there, that part of the sea always stays inundated. There are organisms that they are never exposed to air. Then the upper one is the supralittoral ring. What that means? This is the area that divides the tidal area, the eulittoral zone. So that actually means what? The area that is inundated daily. It becomes either not inundated or it not becomes inundated. Above that, so there is no seawater coming there. You only have some splashes occasionally and sea area that is being. So what did we expect in the subtidal area? We mainly expect there red algae, and those are actually all of it that is here is fine. We have different species. This one is wrong though. Should be higher. Mainly what we found here were either, first of all, an animal, the anemone. Oh, this one is almost dead. Repeated anemone if you didn't see it yet. That one will retract its tentacles as soon as it's out of water or when it's being touched. Then we will mainly find some seaweed species and mainly red algae. So if you remember this from the chromatic adaptation theory from the classes, you will also see that some seaweeds are adapted to different depths in the water column. And red algae have been most successful in colonizing the deeper water areas. And the species we found mostly here, it's already there, is first of all this species, really iconic, because everybody, not even a phycologist, so the seaweed biologists can recognize this one because it's so distinguishable from the other species, but each time it splits in two. It's what we call pseudodichotomy. And this one is called Irish moss, or in Latin, Chondrus crispus. This one is now more and more being interesting to us, also for me personally, because of its commercial value. We are now starting to explore, or starting to investigate what it is being cultivated and be consumed as part of our diet. So that's Chondrus crispus. Then we also had one green seaweed species. Who knows what this is? I thought I said it to some of you. It's an easy name to be said like that. Sea lettuce. Really easy name, right? Ulva. So that's also one you typically find in the subtidal ponds. And then we had some other species. This one is wrong. Positioned. This is Polysiphonia, Buisjeswier, also one of the subtidal areas. And then the last one, which is also positioned wrong here, is Corallina. Coral. This one is a calcifying algae. So just like corals, it also uses calcium carbonate to make part of its body. And every white dot you see once again is actually also carbon deposits. So this is one of the species that will be affected by ocean acidification. And to be honest, but I'm not sure what the reason is. In the past we always found it abundant, and today I've only found it with one or two groups who found it. So is it decreasing? I don't know. Maybe it's something temporal, but it's something I will keep an eye on for the next years. Might be affected by ocean or climate change in general. We will see. Okay, so that's the subtidal pools. Mostly red algae dominating those parts. Then if you go up in the sheltered area, so all of this here should be a bit higher. This is wrong. These are Chondrus crispus. And in the eulittoral zone, we will mainly find algae that are being inundated daily, but also exposed to air quite some time. And in this area, we'll mainly find some green algae species. But I've seen you only collected sea lettuce, which is from the subtidal pools. So is there not grass-like seaweed you have found collected? At least somebody did effort. Okay, great. This is klein darmbier, gutweed. And this is one of the green algae species that is typically restricted to the eulittoral zone. And this was, especially if we came up higher or closer to the fort, this was one we found. And it lives together with the fucus species, so brown seaweed species. And I told some of you that there are 3 brown seaweed species. We have Fucus cellatus, gezaagde zee-ei. We have Fucus mexicanus. Oh, I killed something, I think. This is Fucus vesiculosus, blaasjesspier. No, that's not true. This is something else. Oh no, it is Fucus vesiculosus. You can see it here, the vesicles. And then you also have Fucus spiralis, that's this one. They also occur in zones. Why? I also talked about this, the competitive exclusion principle. The principle of Gauss. Species with the same niche can't coexist, so they need to divide their zone, their fundamental zone, in realized niches, smaller sub-niches. I will explain this more profoundly also, and the excursion is a really important concept. You really have to remember this one. I'll take this home with you from the excursions. Remember it. So this is one of the examples here. Next, alongside the Litorina, so the periwinkle snails that I'm talking about. You also will see in the excursion videos some examples with birds, and you also in the theory class we had an example with barnacles. So these are 4 examples of that principle. Please remember 3 for the exam. Okay? So, zonation. So within the same group you also have zonation. You first have Fucus serratus, which is the most or the least stress tolerant, so it needs most of the time more inundation compared to the other 2 species. Then you have Fucus vesiculosus, and then higher up you have Fucus spiralis. That's the brown seaweed we mainly saw surrounding the foot. Okay? Then if we go higher up, there are no seaweeds anymore, because then there is not enough inundation anymore for Then we reach the supralittoral fringe, and then we had the black belt with cyanobacteria, and then up above that you see them there, you have the different lichens, the yellow ones, but we also have grey ones, several here. These are all lichens. What are lichens? Anybody has an idea what that is? It's a special symbiosis. Exactly, but mushrooms is not the right word. We say a fungus. It's a mutualistic, so a positive relationship between an algae and a fungus. So your algae will provide sugars to your fungus by doing photosynthesis. The fungus in turn will provide protection and also moist. It will keep moist for the algae to grow. So it's a mutualistic relationship, also really important for the example. This is why those lichens are able to grow on really harsh environments such as rocks. There's nothing else for them, but still they manage to grow there. So the zonation here is a bit wrong. This is also a really cool species that doesn't occur here on the rocky shores. It's being washed on shore. This is knotsweed. You can say I think it's not named, but I'm not sure. It's actually named after these big vesicles. It's not from here. Okay, so take home messages for sheltered areas, seaweed dominated species, seaweed dominated communities. The more exposed areas, there you'll mainly find animals. Why? Because they're able to really protect themselves or really stick to the rocks, and they cannot be washed away in contrast to seaweed. That's just selection. If a seaweed starts growing in a more exposed area, it will just be washed away. Okay, the zonation in the exposed areas is less pronounced, but it's still there. So in the subtidal areas, there is no wave action, so that's the same as in the more sheltered areas. In the littoral zone, we mainly find mussels and barnacles. I don't find them here, and the patella. So all these organisms have been adapting to those exposed conditions. Who remembers how these mollusks attach themselves to rocks? Who can help me? The byssal threads, indeed, the mussel has a foot inside its shell, and it produces these byssal threads. You can see them. I will pass it one more round if somebody didn't see it. This is how it attaches itself to the rocks. What is this species? The limpet schaalhoorn of patella, named after the kneecap. It's a gastropod, and it also has a foot, just like the mussel. The foot here is like typically shaped discs, and it uses it to attach itself to the rocks. On top of there are some barnacles. These barnacles are opportunistic. They're weak competitors, so they are easily outcompeted. And they are also, so they either grow on the rocks or they will grow on other organisms. This is what we call epizooism. Epi, on, zoa, or animals. Now what happens in the zonation here is, so the mussels, they actually like to go as deep as they can. But they are restricted to the eutidal zone because if they go lower, they're exposed to predators, starfish. So by predation, this means that the eutidal zone is their lower limit. If they are going too high, they will desiccate. I don't have enough time to feed, so that's their upper limit. Barnacles face the same issue, except for the fact that they're the weaker competitors. So the mussels force them more upwards compared to the mussels themselves. So they usually are restricted more higher up in the eutidal zone. Eulitral zone, I mean. Okay, then we had some snails. These are all the same species. Who remembers what this name was of this species? You don't know? Yeah, the purple snail. So I've been talking about the whelk or the wolf in Dutch earlier, but in X-capsules, this is the other species, the other predator snail. And what is important here to take home is that this species is quite endangered. It was 10 years ago, it didn't come here, it didn't exist anymore, it went extinct. Why? Who has an idea? Especially for the environmental students, they should know this because this was a story we tell in the environmental risk assessment. Somebody said it. Shout it. No, not CO2. What? No, no, something else. Good try. I have been saying this to quite a lot of people. Who can help me? We will stand here for 2 more hours. And answer. Exactly, tributyl tin, TBT. TBT, an antifoulant. So it was used on vessels, research vessels, but also other marine equipment to protect itself from growing from algae and other organisms, for example, as these barnacles. It was being widely used, but its concentrations made that these snails, that the females in this population, or in the population in general in coast, developed a pseudopenis. This is what we call imposex. And because of that phenomenon, of course, there was no reproduction possible anymore, and so your population collapsed. Now TBT is banned, it cannot be used anymore, except for some exceptions. And so concentrations are lower, and now you see that these species is appearing here again. And we also found, some of you found eggs of this species. So it also means that the species started reproducing here again. We also had some other snails, the tolhoorn, not important for today. And then we also had Litorina, the periwinkle snail, if you remember this. Here again, there's also zonation. You have 3 species occurring here. You don't have to remember which one. But it's also important they have the same niche. They are vegetarians. And what I mean by that they will feed on the seaweed and they will also feed on diatoms, anti-diatoms, which I hope you have seen in front of the bunkers, among other places in the tidal pools. These species are also grasshoppers. They also have a foot, but they use that foot to move actively, but they can also use it to really attach themselves to the shore, to the rocks. So remember here there is also an zonation visible. Okay, what else have we seen here? Indeed, then we had common limpet, it's strong enough. So above the supralittoral fringe we have the flood zone, where you indeed have been putting all these shells, these egg capsules and so on. That's mainly the take-home message. The crabs, of course, they are really mobile. There is no zonation pattern there. They will usually restrict themselves to the sub. Okay, what I suggest now is, I don't know if my colleagues are here. And yes, you have the... So one more thing I want to do before we leave is, here you see an estuary. So I would like to ask a few of you to sample some water there, sample some water there, sample some water there, sample some water close to the shore, and we will start measuring the salinity. And I hope to prove this way to show you that there is a salinity gradient in which the animals have to adapt themselves. So maybe some of you Chinese volunteers will go and take some water samples while the others are starting to clean up this mess, so we can return it to the sea afterwards. Okay? So go to Silke to some cups, take some water, and then we can start measuring the salinity.